In this video, we're going to look at the idea of chance and uncertainty within maths. We'll start by looking at the E's and O's. You can see that it's only within first and second level that we cover this, and I'll just give you a second to look over those E's and O's. Now, what's interesting, you'll notice, is that these E's and O's don't mention calculating the probability of an event happening. However, when you review the support material from the Scottish Survey of Literacy and Numeracy, it appears that that is something that they're expecting us to do. So we'll cover how we do that in this short video. With that in mind, I draw your attention to this document here, the Numeracy and Mathematics Progression Framework from Education Scotland, which is very useful and contains lots of information. So if you wish, you can pause the video just now, go to this site, or simply Google National Numeracy and Mathematics Progression Framework and have a look at that. Okay, we'll start then by looking at probability. The probability of events happening lies between two extremes, impossible and certain. And a good activity you can then do with the children is to look at vocabulary words that would describe the different stages between impossible and certain. So here's a few words that I chose to put in. And what we'll do now to help us really understand the meaning of these words is we'll consider the likelihood or the probability of these different 5 events happening. So what would be the probability of a mother giving birth to a baby girl? It'd be an even chance. She's either going to have a boy or a girl. Number 2, leaves falling off a tree in autumn. Now I have to admit that I put this down as certain. However, some students did question me and say, well, Jonathan, what if it's an evergreen tree? So, bearing in mind that this tree is a tree that loses its leaves in autumn, the chance of the leaves falling off are certain. Number 3, getting a 6 on the dice. That's a poor chance or an unlikely chance. Number 4, we all want it, winning the national lottery jackpot. I'm afraid to tell you it's about as close to impossible as you can get. And lastly, getting a 4 on the spinner you see on the screen. Well, actually, there's a good chance of that. It's pretty likely. So what we're seeing here then is that the probability of an event happening can be located accurately on a probability line. But to really have more detailed understanding about that, we need to know all the possible outcomes that can occur. So here's what I mean. We want to make a list of all possible outcomes for the events. And what's worth noticing is that all of these events are equally likely. So if we consider throwing a dice, what are all the different outcomes that could occur when you throw a dice? Well, there's 6 outcomes. You could roll a 1 or a 2 or a 3 or a 4 or a 5 or a 6. So there's 6 outcomes and each outcome is equally likely. What about tossing a coin? Well, if we toss a coin, there's 2 outcomes, a head or a tail. Again, equally likely. And what do you think for number 3? For spinning the pointer? How many outcomes are there? Well, there's 5. There's 5 outcomes. You could get either one of the different colours. We calculate then the probability of an event happening by thinking of the number of wanted outcomes over the total number of outcomes there are. Now, I'm going to talk a little bit more about this line that I've made here, but you'll notice it's separated into twelfths. That is 12 even parts of this one whole. Now, I've done this just to show an example of how you can tie in fractions and fractional language that we've been learning about today in our input. So this is just an example of how you can tie this in. So, how do we calculate the probability of an event happening? Let's think about number 1, getting a tail when you toss a coin. So the first thing is, how many wanted outcomes are there? Well, there's 1 wanted outcome. We want to get a tail. And how many total number of outcomes are there? That is, how many possibilities are there? Well, there's 2. It's either get a head or a tail. So we see then for tossing a coin, there's a 1 in 2 chance. That's our probability. Or if we convert this into an equivalent fraction so that we can have 12 as our denominator, we can place it on our probability line here. Now, the reason I'm doing this, the reason I've used 12 or twelfths rather, is because each of these events, you can change them to an equivalent fraction of a 12th. So what we're doing is here, we're applying some of our fractional knowledge in a different context. So let's have a look at number 2, getting a 3 when you roll a dice. So how many wanted outcomes are there? There's 1. We want to roll a 3. And how many possible outcomes, or what's the total number of outcomes? Well, the total number of outcomes is 6. So we've got a 1 in 6 chance, or if we convert that into twelfths by timing both number by 2 or doubling, we see that's 2 twelfths. Think about the one for number 3 then. Being born in the month of March. What's the probability of that happening? Well, hopefully you said it was a 1 in 12 chance. There's one outcome we want, the month of March, and there's 12 months it could happen. What about number 4? Choosing a red cube at random from the bag. Well, we can see here that there's 4 red cubes, and there's 5 red cubes, and there's 5 in total. So that would give us a probability of 5 out of 12, or 5 in 12, 5 twelfths. Number 5, getting a 5 on the spinner. Very likely. 3 over 4. Well, we can convert that into 9 twelfths. And the last one, choosing a blue bead at random from the bag. Well, there's 12 possible outcomes, but there's only one and there's 11, there's 11 outcomes that we could get because there's 11 balls, 11 blue balls, but the total number of outcomes, the total number of balls is 12. So that would be 11 twelfths. Let's have a look then at just making this a little bit more challenging again. What's the probability of these different events happening? Thinking about how we calculate the probability of event. So for question 1, what's the probability a blue ball will be chosen? So we think of the number of wanted outcomes, 2 blue balls, versus the total number of outcomes, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 blue balls. So what would the answer be? So if there are 10 balls in total, and there are 2 that you want, you are 2 tenths. There's not a 2 tenths there, so we must have to find an equivalent fraction or simplify. So looking at the different options, we can see that 1/5 is equivalent or a simplified version of 2 tenths, and we've done that by dividing by 2. So the next question then is we choose one blue ball and do not replace it. What is the probability a blue ball will be chosen now, and why? So we now have one possible outcome, that is, there's only one blue ball left to choose, but we now only have 9 items to choose from because we've removed the ball. So the answer then would be D. There's a 1 in 9 chance. So why bother learning this? Well, I think if we think about the capacities that we're looking to develop in our learners of being confident individuals, effective contributors, responsible citizens, and successful learners, we can see that actually learning about probability is a way for them to develop these attributes. I'm thinking about things like in terms of considering risk and reward benefits, or risky behaviours, or even how they manage their money. I think it's important for children to have a sense of probability and likelihood. Now, just to finish, here's a fun little activity to test the learning that we've been doing. Do you want to win a goat or a car? Now, the way this works is that you're on a game show and there are 3 rooms. Behind 2 are goats and behind 1 is the car. Where your job is to pick one door. When you pick a door, the host will reveal one of the rooms you didn't pick that has a goat in it. He will never show you the car. This would leave you 2 rooms to pick from. The one that you chose initially and the one the host didn't reveal. The host then says that you can change your choice. My question is, do you? And if so, why? Now, to make this easier for you, you can see the instructions there. Pause this and have a think about what you think would happen. What should you do? Should you stick or should you switch? Now, if you're anything like me the first time you heard this might have given you a little bit of a headache. The answer is you should switch. And actually, if you stick, you have a 33% chance of winning the car. But if you switch, you have a 66% chance of picking the car. Now, if you want to find out more about this, you can look at the diagram on the screen, or you can view either one of those 2 videos listed at the bottom. This is called the Monty Hall problem. If you want to research this, if it does start to hurt your head, don't worry about it. We can talk about it when I'm with you in Inverness. just to finish then, here is our references. And there we are.